Hi everyone, welcome back to Sisya Class YouTube channel. So in today's session, we are going to learn about amines. I hope you have seen the last session. I hope you have solved the questions related to that. So these are one-shot sessions. We cover all the important concept, then we solve questions based on it. Obviously, you have to solve many more questions in order to secure good marks in the examination, right? And we will do that obviously, right? Once we understand the concept, we are going to solve questions from the last 5 years. We have to do that. We have to revise it multiple times. Only then we can secure good marks. Okay. So I hope we are following that. I hope we are practicing more and more questions. Okay. So let's begin, everyone. Before we start, I want to give you one information regarding Sasya class. Then we are going to continue with our session for amines. Okay. All right. Okay, so as you all know, all those who are following our EAPCET series, there is a 1 year course that we have started for grade 3 to 10. Only maths will be taught to you by IIT and NIT experts. And in this 1 year course, your entire CBSE, ICSE and state board syllabus will be covered. Whatever board examination you are going to give. So this course is available for grade 3 to 10 at just rupees 999. So per day cost, if you calculate, it will come out to be somewhat less than 3 rupees. Very cheap, and you are getting help from the IIT and NIT experts. So I hope you take help of that. And you can download our app by using the scan code, or you can search it in the Play Store as well. This course will start from May 5th. And if you enroll in this course, you can take help of Sisya AI as well, in which you can ask your doubts. There are 3 features which are available to you if you enroll in the course. There is text-to-text doubt solving, speech-to-text doubt solving, and image-to-text doubt solving also. So please hurry, join this course and learn maths from IIT and NIT experts. So let's now begin with our session for today. Before we start, let me introduce myself. So my name is Nidhi Narwal and I have 6+ years of experience teaching JEE, NEET and other competitive examination. In today's session, we will learn about EAPCET. I've done my post-graduation from IIT Bhubaneswar and we have completed so many different chapters for your EAPCET preparation. And this entire session is for both TS as well as AP. So don't get discouraged that this is only for AP. No, we are covering both parts. The syllabus is exactly same. The pattern of question is also exactly same. And we are covering the concepts for both examination. So please understand the concept, see the questions also, and then revise it yourself. Solve more and more questions, build your confidence, and then definitely you will secure good marks. Okay. So let's start, everyone. Let's begin with our session. So first of all, we will see the contents. What are we going to discuss today? Let's see. So we will learn about what are the topics we will discuss today. We will learn about aliphatic and aromatic amines, first of all. Okay. So we will see the methods of preparation, the types of reactions which are shown by them, the different ways in which you can separate them. We will learn those things and then we will solve questions based on it. Okay. Next, we will learn about amines, cyanides and isocyanides, quite similar. So in amines, you have both aliphatic and aromatic, obviously. Then we have cyanide functional group, how you can interconvert them, what are the different ways in which you can prepare them. And that is how you will find the questions are also asked. There will be multi-step question in which you have to identify X, Y, and Z, let's say. So everything is interconnected. If you know how to prepare X, then only you can comment about preparation of Y, obviously. Okay. Next, we will talk about nitro compounds and a diazonium salt. Again, make a star mark over diazonium salt. Okay. So definitely they will ask you a question from there. There are different types of aromatic compounds that you can prepare from diazonium salt. So you should know the name of such reactions, how we can prepare them, and what is the advantage. Why can't we use other different ways to prepare it? Why do we need diazonium salt? We will cover that as well. Okay, so let's start, everyone. Let's begin with our session for today. So first of all, we will talk about the methods of preparation, obviously. Okay, so first is reduction of nitro compounds. The simplest way in which you can prepare your amines is by reducing your nitro compounds. Okay, so you have your nitro compound 10 in the presence of HCl or Fe in the presence of HCl in acidic medium will give you your respective amine. Okay, so the alkyl group will remain as it is. What are we changing? We are changing the nitro group to amine group, and that is how you can prepare it. Okay, great. What else we can do? We can also do the ammonolysis of alkyl halides. What is ammonolysis of alkyl halides? We are replacing the halogen functional group with amine group. Ammonolysis. That is all. So what are we doing? Substitution reaction. Halogen is replaced. This is your leaving group. And in its place, you have your nucleophile NH2. So this is a nucleophilic substitution reaction. As simple as that. Okay. Now, in this ammonolysis reaction, you can prepare your 1 degree amine, but we don't prefer this method. Why don't we prefer this method? Because there are chances that once you prepare this 1 degree amine, then further substitution may occur and you will get a mixture of different amines, primary, secondary, tertiary. So you have to write in your equation itself that there are drawbacks. You have to remember other different methods. You have to first choose which one should be taken in excess. That will decide what will be your final product, what would be formed in excess. Okay, so please remember that as well. Let's see the next one. Reduction of nitrites. So you have seen the reduction of nitro compounds, Fe in the presence of HCl or tin in the presence of HCl. That was one way. You can also reduce your nitrites or cyanide. It means the same thing. Okay. So see the reducing agent that you are taking here. Lithium aluminium hydride, very strong reducing agent. Okay, it can reduce the aldehydes, your ketones, your carboxylic acid, your nitrites. As you can see that amides also can be reduced by lithium aluminium hydride. It is the strongest reducing agent. There is no selectivity involved. You will give it a functional group. Most of them it can reduce. Ester also. Okay, and in its place you can also do the hydrogenation. So H2 in the presence of nickel, platinum, palladium, any one of them can also give you the exact same product. So you don't have to write both of them. This is just one example. You can reduce it with either lithium aluminium hydride or H2 in the presence of nickel. Okay, remember that. You don't have to use them together. It is a or situation. Either use lithium aluminium hydride or H2 in the presence of nickel, platinum or palladium. Okay. See, one more thing. You have to see how many carbon atoms are present in your starting material and how many carbon atoms are there in the final product, because you will find such questions are asked. Okay. They will give you one reaction. They will ask you this is the final product, some XYZ, and some characteristics of the final product. Are the number of carbon atoms same in the final product as the reactant? Are there more carbon atoms than the reactant? So they can ask you such questions. So please notice that also by writing the reaction. You don't have to write it separately when you are revising it, but yes, you have to observe that because it can be asked in a question. Okay, so please notice the number of carbon atoms in the reactant and the product must come out to be same. Please don't reduce the number of carbon atoms. Please don't write NH2 in the presence in the place of cyanide itself. That would be wrong. Don't do that mistake. I will give you one example. Let's say you start with this nitrite. I can see 2 carbon atoms in the reactant. I want to reduce it. What should be the final product? Do we understand this thing? I have 2 carbon atoms in the product also. You should not write CH3NH2 here. That would be wrong. So please count the number of carbon atoms and see are they matching in the reactant or product. Okay. See the next question or next equation. Reduction of amides. How can we reduce amide? Similar method with lithium aluminium hydride. You can reduce amides also. And please notice what are we doing here? In here also the number of carbon atoms in the reactant and product are same. So you are starting with RCONH2 and in the product you have RCH2NH2. Okay, so please remember number of carbon atoms in the reactant and product must be same. Okay, see the next question. All right, not the next question, other different reactions that you should know about from amines. Okay, so we have a very important method by which we can prepare what type of amine can be asked. 1 degree amine. Can we prepare secondary amine by Gabriel's halide synthesis? Can we prepare 3 degree amine? No, you cannot prepare secondary or tertiary amine by Gabriel's halide synthesis. You can only prepare 1 degree amine. Do we have to remember this information? Yes, you have to remember this information. So please see what type of amine you have prepared. 1 degree amine. Not secondary, not tertiary, primary amine we are preparing. Okay, so you have theramide. This is theramide. Okay, it reacts with your alkyl halide depending upon what type of alkyl halide you have taken. You will get the final product. So we are doing nucleophilic substitution. SN2 reaction. So what type of alkyl halide we should start with? 1 degree alkyl halide. Can we start with secondary? Can we start with tertiary? No. In that case, SN2 reaction is not favored. Simple. You have learned that thing in haloalkanes and haloarenes. We are applying that information. This is not new information for you. We have done that already. You know about the different types of substitution reaction. Okay, and you also know what type of alkyl halide favors which substitution reaction. We are just applying that information right now. So what are we doing here? SN2 reaction. What type of alkyl halide favors SN2 reaction? Primary. Okay, so you will start with 1 degree alkyl halide. Okay, and that is how you will get 1 degree amine. So this is a special method for the preparation of which amine? Primary amine or 1 degree amine. Okay, next, Hofmann bromamide degradation, again important. And what is so important about it? You start with amide. You do Hofmann bromamide degradation, Br2 in the presence of KOH, Br2 in the presence of NaOH. You can choose your base, does not matter. What is important? Yes, obviously you have to remember the reagent, but you have to remember that in the final product, I have 1 carbon atom less than the reactant. See, it will help us to see how many carbon atoms were there in the reactant and in the product when you will solve questions. Okay, so this one has 1 carbon atom less than reactant. So you must remember this, that in Hofmann bromamide degradation, we are removing something, degradation, there is 1 carbon atom less than the reactant. Please remember that. You have your amide and you are preparing amine. Do we have to remember the byproducts? No. Reagent? Yes. Reactant, obviously. And in product, you have 1 carbon atom less. You must remember this information. Okay. Now, let's see the next thing. How do we compare the basic character of amines? Again, very simple, easy peasy questions are asked from here. So you can compare the basic character, but you have to read the question very carefully. Are they asking you to compare the basic character in aqueous medium or in gaseous medium? Do we have different order of basicity? Yes. So please notice that in the question itself. Okay. So if you compare the basic strength in aqueous medium for aliphatic, it is secondary, then primary, then tertiary amine. Okay. If you compare aliphatic with aromatic, aliphatic amine is more basic than aromatic amine. Okay. So secondary, then primary, then tertiary. This is the order that we will follow. Okay, great. What about the basic strength in gaseous phase? This one is simple. Tertiary, then secondary, then primary. Why are we considering tertiary to be more basic in gaseous phase? Because there are 3 alkyl groups attached. How do we compare the basic strength? How easily we can donate the lone pair of electrons. So if we can donate the lone pair of electrons easily, we will consider it to be a strong base. If the species you have taken, it does not want to donate that lone pair of electrons, you will consider it to be a weak base. Simple. Okay. So tertiary, secondary, primary, if you consider gaseous phase, for aqueous phase, secondary, then primary, and after that, tertiary. Okay. Now, let's see the next thing. Carbylamine reaction. Why is this important? This is the method by which you can identify whether 1 degree amine is present in your unknown sample. Okay, you want to differentiate between primary, secondary, and tertiary amine. You want to do a test. You can do carbylamine reaction. This carbylamine reaction is only given by 1 degree aliphatic and aromatic amine. Both of them, yes. And it gives you this isocyanide, which is a foul smelling compound. It gives you a very foul pungent smell. That is the way to identify it. See, whenever you are trying to do a test, either you will look for a color change, maybe some gas is getting evolved, or maybe there is some smell that is coming from the reaction. These are the 3 observations that we can easily identify. So such things are what we do in case of test. For example, UCAS test, in which you have differentiated between primary, secondary, and tertiary alcohol. There you were looking for precipitate because we can easily observe it, right? Here we are looking for a foul smelling compound, isocyanate. So if you can smell that it is pungent, you will say yes, it is your primary amine. Maybe aliphatic or aromatic, we don't know, but it is for sure a primary amine. Okay, so this is what we have written. Primary amine in the presence of chloroform and KOH will give you your isocyanide. And you must remember this reaction. First of all, it is a name reaction. Obviously, it is important. Second thing, it is the test for 1 degree amine. Okay, see the next thing. Reaction with nitrous acid. By reaction with nitrous acid, if you start with your aromatic amine, you will form your diazonium salt, first of all. Okay, and the nitrous acid is this one. So why are we not adding the nitrous acid directly? Because it is highly unstable. It will decompose if you add it directly. So we prepare it in situ within the reaction. You start with sodium nitrite plus HCl. It will generate this nitrous acid. So sometimes, in most of the cases, they will write NaNO2 plus HCl. But otherwise also, if they write HNO2, don't get confused. They are talking about diazotization only. Okay. Please understand, HNO2 is not added directly. It is prepared in situ in the reaction. So if the examiner wants to confuse you, he or she will write HNO2 on the arrow. Don't get confused. It is same as NaNO2 plus HCl. Okay. Next. So what happens if you have 1 degree aliphatic amines? They will react with nitrous acid. You will get the diazonium salt, but that diazonium salt is highly unstable. So it decomposes to give you alcohol in the end. Okay. So 1 degree aliphatic amine plus nitrous acid. See, we have written nitrous acid, but how we have formed it? NaNO2 plus HCl. So you should know that. Okay. So it will give us diazonium salt. Yes. Great. Then what happens? It is unstable. Because in case of aromatic amine, that diazonium salt is stabilized by resonance with the aromatic ring. But there is no such thing in case of aliphatic amine. So here your diazonium salt is unstable. If it is unstable, it decomposes. It decomposes to give you alcohol in the end. And this question has also been asked before. So please remember this reaction. Okay. Now, what happens if you have taken 1 degree aromatic amine? Here the diazonium salt is stable, but in a certain temperature range, 0 to 5 degrees Celsius, if you increase the temperature here also, it will also decompose. So temperature is important. Yes, you have to remember the temperature conditions. Otherwise, this diazonium salt, although it is in resonance with the aromatic ring, can decompose. Okay, remember that. Otherwise, this will also decompose. Okay, this is benzene diazonium chloride. BDC, or we simply write it as BDC. Okay, yes. But we are covering each and every chapter. Okay, as I have told you, you have to read all the chapters. Now, based on how many questions I asked from there, you can give it less amount of time, but don't leave the chapter altogether. Okay, Bhavya? Please read each and everything, but after you are done with the entire revision, some of the chapters you have to focus more, revise it multiple times, but don't neglect any chapter. We have covered each and everything, so you can revisit our sessions also. Okay, Bhavya? All right. Let's see the next thing. And yes, you have to solve questions also, Bhavya, right? Don't just look for the content. Please practice questions also, and don't get disheartened. But you have to revise all the chapters. You cannot leave anything so that you can score good marks without this chapter. Don't do that. Okay. All right. Coupling reactions. The last thing, how we can do the reaction with phenol. See, coupling reactions are very specific for diazonium salt. How will they ask you the question? What is the color of dye that is formed from here? Do we have to remember the color of the dye? Yes, you must. Okay. So you can see the reaction with phenol. Why are we doing reaction with phenol? And we will see one more with aniline, because they have electron rich substituent on the aromatic ring. What are we doing here? We are doing electrophilic aromatic substitution, everyone. You have done that in the last session. I hope you have seen that. Okay. We have covered different types of electrophilic aromatic substitution reaction in the last class. We have seen the entire mechanism also, right? Same steps, only the type of electrophile is different. So there also we have learned that if you change the electrophile, the three steps are same: generation of electrophile, attack on electrophile, and third is removal of proton. So we are doing just that here also. Here the electrophile is this. This is your electrophile. This is your electron-rich aromatic ring on which you are doing the substitution. And if you do the reaction with your phenol, your product is para-hydroxyazobenzene, and the color of the dye is orange. Please remember the color of the dye. Okay. See the next thing. What about the reaction with aniline? You will form a yellow dye in that case. Please remember the color. Okay. All right. So this is all about the different types of reactions that we should know about for amines. Now let's solve some questions. Let's see some last year questions, the concepts that you have to focus on. Okay. So read the question now. You have carboxylic acid. You are treating it with ammonia and heating it. What will happen? See, in aldehydes and ketones, substitution reaction does not occur. But in case of carboxylic acid and its derivatives, you can do the substitution reaction. Okay. So in this case, you are forming amide. Okay. And that amide, what is the type of reaction you are doing here? Br2 in the presence of NaOH. We have learned about this reaction just now. We are doing Hofmann bromamide degradation. What happens in Hofmann bromamide degradation? One carbon atom less is present in the product than what we have taken in the reactants, everyone. Okay. So this is Hofmann bromamide degradation. From amide, you are forming amine. Okay. See now the options. a primary amine with the same number of carbon atoms as in P. I have one carbon atom less than P, right? So this is wrong. A primary amine with one carbon less than in P. This is your Hofmann bromamide degradation. And I told you in the beginning itself that while reading Hofmann bromamide degradation, please count the number of carbon atoms in the reactant and product. You will find there is one carbon atom less. Done. This is one simple question that has been asked before. Let's move to the next question. Okay. What are X and Y respectively in the following reactions? Okay. So this is amide. From amide, you are forming aromatic amine. And notice there is one carbon atom less. So what do we notice from here? If there is one carbon atom less than that of reactant, we are doing Hofmann bromamide degradation. So this is Hofmann bromamide degradation X, NaOH plus Br2, NaOH plus Br2. So the answer is either D or C. Let's see what is Y. In this case, you have exactly the same number of carbon atoms as you have in the reactant. So we are doing reduction for sure. We are forming amine from amide. But what is the reagent we are using in which the number of carbon atoms remains same? We are using lithium aluminium hydride. Okay. So this must be lithium aluminium hydride. Correct answer is option B. Why are we not using sodium your borohydride? Because sodium borohydride only reduces aldehydes and ketones. It is not that strong that it can reduce your amide. So it is specific for aldehydes and ketones. Please don't use NaBH4 everywhere. Strong reducing agent is lithium aluminium hydride. Okay. So your correct answer is option B. Let's see the next question. We are asked about X and Y, right? Yes, this is okay. All right. The product of an amine X with benzene sulfonyl chloride produces the product which is insoluble in alkali. So this benzene sulfonyl chloride, we call this as Hinsberg reagent. Hinsberg reagent reacts differently with primary, secondary and tertiary amine. Okay, with primary amine, it will give you a soluble product with alkali. So it is definitely not primary amine. With secondary amine, it will give you an insoluble product. With tertiary amine, it will not react. Okay, so we are looking for secondary amine. All right, so R1, NH, R2. Okay, it gives you an insoluble product with alkali. From this fourth statement, we have observed that this must be secondary amine. Now, this secondary amine reacts with ethanoyl chloride. And they're asking you what will be the final product that will be formed. Okay, so how do we write this reaction? Just remove hydrogen from here and chlorine from here. There will be loss of HCl and this will be your final product. COCH3. Okay. See which one matches correctly with our final product. This one, right? R1 is different, phenyl ring. R2 is different, methyl. NHCO. Okay. So option A is correct. In this case, C, you have two alkyl groups. But if we start with a secondary amine, this we can form with a tertiary amine. That is not the correct answer. In this case, you don't have any carbonyl group. In this case also. The correct answer is option A. And how do we come to this conclusion? We know about Hinsberg reagent. That Hinsberg reagent, if it reacts with 1 degree amine, it will form a product that is soluble in alkali. If it reacts with secondary amine, it will form a product that is insoluble in alkali. And if we react it with tertiary amine, see, we need hydrogen in order to react it with benzene, sulfonyl chloride. If you don't have any hydrogen available, there will be no reaction. So you don't have to worry about tertiary amine altogether. This is another way in which you can differentiate between primary, secondary and tertiary. Okay. I hope that is clear. All right. See the next thing. Yes, focus on. You have to practice more and more questions for that. All right. Yes, it is secondary amine. Correct, Lex Rex. All right. See the next question. Arrange the following in increasing order of their boiling points. Okay. So you have N-ethyl ethanamine, you have butanamine, and you have N dimethyl ethanamine. So basically we have three different types of amines. We have primary, we have secondary, and we have tertiary amine. Three different types of amines are given to us. Okay. Now we have to compare their boiling point. How do we compare the boiling point? The first thing is you compare the molecular mass. Greater is your molecular mass, more will be the boiling point, because in that scenario, your van der Waals forces of attraction are stronger. That is one scenario. But in case of amines, you have hydrogen bonding also. So just compare hydrogen bonding. In case of 1 degree amine, the extent of hydrogen bonding is higher. Why? Because there are greater number of hydrogens available. In case of secondary amine, the extent of hydrogen bonding is less than primary amine. And in tertiary amine, you will not see any hydrogen bonding. So how do we compare the boiling point of primary, secondary and tertiary? Primary will have the highest boiling point, followed by secondary amine, and then we will have tertiary amine. Okay. Boiling point depends upon primary amine, secondary amine, and finally tertiary amine. Okay. So in this case, N-ethyl ethanamine, this is secondary amine. This is primary. N dimethyl ethanamine, this is tertiary amine. So the maximum boiling point will be shown by second, then your secondary amine, first amine that is given, and finally this third one. Okay. So which option matches with our observation? Second, then first, then third. Option D. That is all you have to do. So they can change the type of amine in the next examination. You don't have to worry much about the type of amine or what type of alkyl groups are given there. You just have to remember we have to compare primary, secondary and tertiary amine. Okay. See the next question. Arrange the following in the order of decreasing basicity. How do we compare basicity? We have learned this thing in GOC also, if you remember. In order to compare the basic strength, you have to see how easily we can donate the lone pair of electrons. If the lone pair of electrons are easily available on us and we have the tendency to donate it as well, we will consider it to be a stronger base. We will consider the basicity to be high. Okay. So in this scenario, you have different types of amine. Look for the hybridization here. If you have sp3 hybridization, percentage S character is less, electronegativity is less, tendency to donate the lone pair of electrons is more. Okay. So please compare it based on hybridization. As the percentage S character increases, electronegativity increases and your basicity decreases. Okay. So in sp hybridization, the percentage S character is maximum 50%, then sp2 33.3%, then sp3 25%, So as the percentage S character is increasing, this one has highest electronegativity. If you have higher electronegativity, you don't want to donate that lone pair of electrons. You want to keep the lone pair of electrons on yourself. Okay, so if you want to keep the lone pair of electrons on yourself, you will not behave like a strong base. You will be a weak base. Basicity will be this. Okay, so here the hybridization is sp3, here it is sp2, and here it is sp. So the correct order is maximum basicity, then first, then second. Option B. This is the order of basicity based on percentage S character. And you can apply that same information on the stability of negative charge also. You must have done that when we have talked about hydrocarbons. We do the exact same thing there also. Okay. See the next question. The sequence of reagents which will convert para-methyl aniline to para-methyl benzoic acid. Para-methyl benzoic acid. Okay. So we are not doing anything with the methyl group, right? What are we converting? From amine, you are preparing carboxylic acid. So how can we proceed in that scenario? Let's see the options. Options will help you. Okay. So they are saying oxidize at first. Cheminophore is a strong oxidizing agent. Okay. But oxidation of NH2 will not help us to get carboxylic acid. Okay. So this can't be our correct answer. This one. Do the diazotization first. Okay, we can do that. So from, don't do anything with the methyl group. Okay, it does not change anything. First we are doing diazotization, NaNO2 plus HCl, 0 to 5 degrees Celsius. We will get diazonium salt. Now from this diazonium salt, you can do the substitution easily. This is why we prepare the diazonium salt. It is so easy to prepare so many different aromatic compounds if you have prepared the diazonium salt. Okay, so we will do the Sandmeyer reaction and we will replace this N2 group. It can be lost easily with cyanide group. Why? Because then we can do the hydrolysis and get a carboxylic acid group. Okay, so which option is telling you to prepare a cyanide group, a nitrile group to replace your diazonium group? Option number C. That will be a correct answer, but see the whole reaction as well. And finally, do the hydrolysis. And that will give you this product. Okay, cyanide on hydrolysis gives you carboxylic acid. That is how you can proceed. And what is the name of the reaction that we have written here? This is Sandmeyer reaction. Name reaction to please to remember it. Okay, you can prepare your chloro group. You can do the substitution of chloro group, bromo group on your aromatic ring with the help of Sandmeyer reaction, and your cyano group also, a nitrile group, however you want to call it. Okay, so your correct answer is option C. That is how you can prepare it. Let's see the next question. Which of the following reactions are used in the preparation of aliphatic primary amines, 1 degree amines? Not aromatic, aliphatic. And we have learned about this reaction in the beginning itself. I hope you remember them. Okay. So Gabriel thalamide reaction, I told you specifically, it is used for the preparation of 1 degree aliphatic amine, because on the aromatic amine, you cannot do the nucleophilic substitution because of the resonance with the aromatic system and partial double bond character. On your aliphatic amine, the substitution on your, aliphatic alkyl side, the substitution is easier. That is how you prepare the 1 degree aliphatic amine. Okay, so we can prepare it from Gabriel Thalamide reaction. Yes, we can. Hofmann bromide degradation, in which you prepare it from amide. There is 1 carbon atom less than the starting material. We have done 2 questions based on it as well. So yes, we can prepare 1 degree amine from Hofmann bromide degradation also. Okay. Can we prepare it from carbylamine reaction? In carbylamine reaction, the test for 1 degree amine, you start with 1 degree amine. You don't prepare it. What are we preparing? A foul smelling isocyanide, right? But they are asking you to prepare aliphatic primary amine. So this is not the correct answer. And from Sandmeyer reaction also, you have just now seen it. From diazonium salt, you prepare maybe chlorobenzene, maybe bromobenzene, maybe cyanobenzene. So you do the substitution there. You don't prepare your 1 degree amine from Sandmeyer reaction. Another thing, Sandmeyer reaction is given by aromatic diazonium salt. But we are asked to prepare aliphatic 1 degree amine. So obviously Sandmeyer reaction is not the correct answer. Okay. So your correct answer is first and second only, option B. That is how you can answer it. So if you have learned the different ways to prepare the amines as we have covered, you have seen the different tests by which you can differentiate between the amines, you can answer these questions so easily. Okay, and there are multiple such questions that have been asked before. You have to practice more and more. Okay, see the next question. Identify what is Y in the following reaction sequence. Okay, so what is this reaction? From amide, you will get amine. And you have seen this reaction now for the third time. What is this reaction? Hofmann bromide degradation. We are doing degradation. So the amine will have 1 carbon atom less than the reactant, that is amide. Okay. So you will get amine for sure. And this is 1 degree amine with 1 carbon atom less than the reactant. Is this X? Yes, it is X. Now what are we doing next? We are doing diazotization. You have seen this also. So we will get diazonium salt from here. Yes, and the diazonium salt that you prepare from 1 degree aliphatic amine, you also know that it is highly unstable. So it decomposes to give you alcohol. Okay. So you will get diazonium salt, but it is unstable because it is not stabilized by resonance as we see in aromatic diazonium salt. Okay. So on hydrolysis, it will give you alcohol. Methanol. Okay. See which one. They are asking us about why CH3OH is your correct answer. That is how you can solve it. So they will ask you multiple different concepts in one question itself. They will ask you 2 different sets of reaction. Okay. If you don't know the first set of reaction, how will you answer the second part? Okay. So in organic chemistry, everything is interconnected. If you don't know the first part, you can't identify X. Obviously, you can't identify Y, and sometimes they give you Z also. They will ask you the name of the reaction also. So focus on the name reaction. Remember the oxidizing and reducing agents. Revise them again and again. Okay. See the next question. Choose the correct order of basicity of the following. So you have a 2 degree amine. You have 1 degree amine, ammonia, and 1 degree aromatic amine. How do we compare the basic strength? As I have repeated multiple times, you have to compare the basic strength on the basis of how easily a certain species can donate the lone pair of electrons. So if it can donate the lone pair of electrons easily, you will consider it to be a strong base, correct? So if you talk about your aromatic amine and you compare it with all the aliphatic amines that are given and ammonia, here the lone pair of electrons is in conjugation, right? With the aromatic ring. If the lone pair of electrons is delocalized. Delocalized, it is moving within the system. Because of delocalization, it is less available. If it is less available, it can't be donated easily. So if you compare your aromatic and aliphatic system, your aromatic amines are less basic. First of all, do this comparison. This is the comparison of basic strength. Aliphatic amines are always more basic than aromatic amines because in aromatic amines, the lone pair of electrons is delocalized. It is delocalized, so less available, less basic. Now, we have to compare between different types of aliphatic system, right? So, if you have the option to choose between ammonia, a primary amine and a secondary amine, how will we compare? You have two alkyl groups here which are increasing the electron density on your nitrogen in case of secondary amine. If they're increasing the electron density on nitrogen, that means you have greater availability of charge density that can be donated. In case of ammonia, hydrogen does not do anything. It will not give the electron density. It will not take the electron density as well. Does not do anything. So ammonia will be in the end, but before your aromatic system for sure. And if you compare your primary and secondary, obviously, in this case, you have only one alkyl group. So only one alkyl group is increasing the electron density. So you may write it like this also for comparison. And based on which particular species is asked to you in the question, you can choose the order correctly. Okay. So in this scenario, it will be A, then B, then C, and finally D. Option B. Like that, you can compare the basic strength for different amines. Okay. See the next question. The order of boiling point of the following compounds. We have done this before also. How do we compare the boiling points? By comparison of hydrogen bonding. If hydrogen bonding increases, boiling point will increase. We have done a similar question in which they have given you the name of amines. Now they have given you the formula. Great, good for us. We can identify the type of amine easily. Okay. So you have a tertiary amine, you have secondary amine, and a primary amine and a secondary amine. So if you compare between tertiary, secondary and primary, boiling point depends upon hydrogen bonding. If hydrogen bonding increases, intermolecular forces of attraction are strong, so it requires higher temperature to break those bonds. So your boiling point will obviously increase. And if you compare between primary, secondary and tertiary amine, primary amine will have the greater extent of hydrogen bonding, then secondary amine, then tertiary amine. Okay, because you have greater number of hydrogens available here than in this scenario, then in this scenario you don't have any hydrogens. You can't see hydrogen bonding obviously. Okay, so primary, secondary, then tertiary. So your correct order is, this is my primary amine, then secondary amine, and then these are the amines which are written. I'm not writing the degree here. This is the comparison of amines based on the type. I will write primary, secondary, and tertiary. Don't get confused between the two. And these are the options I have written. Okay. These are not the type of amines that one time I am saying primary, secondary, tertiary, the other time I am writing secondary, tertiary, primary. No, these are the options which are mentioned in the question. I am writing them here. Okay. So it is 2, 3, 1. Option D. Okay. See the next question. Benzamide on Hofmann bromamide degradation. You have amide. You are doing Hofmann bromamide degradation. What will be the product? Amine, obviously. Okay. And then you are reacting it to it CHCl3 in alcoholic KOH. So what are you doing? Carbylamine reaction. How will they ask you the question? See, in this case, they are just asking you what is the reaction that is shown by X to Y. But they can ask you what is the reaction which is shown from benzamide to X also. So you should know that as well. This is Hofmann. So I hope you understand the importance of Hofmann bromamide degradation. We have solved so many different questions, and this Hofmann bromamide degradation is asked one way or other, right? Maybe the entire question is based on it. Maybe it is all involved in certain steps, but you are writing the name reactions again and again. So please revise them. Okay. Next, what is this? Carbylamine reaction. That was the entire question, but I will write the entire reaction as well. C6H5CONH2, benzamide, Hofmann bromamide degradation, aniline, 1 degree aromatic amine, isocyanide, foul smelling compound. So please remember, carbylamine reaction is shown by both 1 degree aliphatic amine as well as 1 degree aromatic amine. Okay. So the question was, what is this step? You will write carbylamine reaction. Okay. See the next question. In the given reaction sequence, what is it? See, they have asked you 3 different products here. You want to solve for Z, you have to know X and Y, obviously. Okay. So what are we doing in the first step that we have done in the very first reaction also, if you remember? Carboxylic acid, the substitution, and you will form the amide. Okay. So this is the reaction sequence. We are preparing the derivative of carboxylic acid. Which derivative? Amide. This is X. And then Hofmann bromamide degradation. This is Y. This is benzamide that you have just now written. And then carbylamine reaction, isocyanide. Okay. So option C. Please don't write option D. We are not forming cyanide. We are forming isocyanide. There is a difference. Here, the nitrogen is your donor atom. Here, the carbon is your donor atom. We consider them to be ambidentate ligands if in a particular nucleophile, not ligands, ambidentate nucleophiles or ambident nucleophile. Similar thing you see in coordination compounds also. There we call it as a ligand. They have the exact same properties. The name are different. Okay. So ambident nucleophile in which we have 2 different donor atoms, but only one of them is used at a time. Okay. So we are forming isocyanide, not cyanide. Don't get confused between the two. Okay. See the next question. The reagents, chemicals X and Y that convert your cyanobenzene to Schiff's base. So in this case also, we are going to react cyanobenzene with, you have to choose which particular reagent such that you will get a Schiff's base. Okay. So this is your cyanobenzene. Okay. So if we do the, what is this tribal H? This is a mild reducing agent. It gives you partial reduction of cyanide group to aldehyde. Okay. Diisobutyl aluminium hydride. It is a weaker reducing agent than lithium aluminium hydride. If you use lithium aluminium hydride, it will give you complete reduction. It will give you amine. But if you want to prepare aldehyde, you want to do the reduction partially, then you will use diol H, diisobutyl aluminium hydride. They will not write the complete name, they will write diol H only. Okay, but you should know the property. Partial reduction okay. And if you have aldehyde, it does not show substitution reaction, it shows nucleophilic addition reaction. Okay, so let's see, we should react it with NH2OH. See what will happen. Write it in this way. And now eliminate water. Okay, and connect the carbon and the nitrogen with a double bond, and it will give you your respective Schiff's base. Okay, like this. So I will write it as C6H5 CH double bond NOH. Okay, so the correct set of reagents are option A. All right, that is how you can prepare the Schiff's base. So this reaction is the first part. We are using amine reduction. In the second part, you're talking about nucleophilic addition reaction of aldehydes. So if you don't know about the reactions of aldehydes and ketones, you will not be able to answer this question. So please read the entire organic chemistry as a whole. Okay, you have to connect alcohols with aldehydes and ketones, aldehydes and ketones with carboxylic acids with amines esters. You will be asked such sequence-based questions. Okay, see the next question. Last question. In the given reaction, what is X and Y? Okay, again, you have done this so many different times, but see, you have benzamide, you are forming an amine which has one carbon atom less than the reactant. What are we doing? Hofmann bromamide degradation. We have talked about it so much. Okay, so this Y is for sure Br2 in the presence of some base, NaOH, KOH, up to you. Okay, or you can write Br2OH minus. This is Hofmann bromamide degradation. And what is this X? Reduction in which you have same number of carbon atoms as this. Okay, so what is X? Lithium aluminium hydride. And what is Y? And you are done. Okay, so this is how you can answer this question. All right, so I hope this part is clear. Let me see the comments. Okay, I hope everything is clear what we have learned today. I don't see any doubts are being asked here. So after we are done with this session, the PDF will be available in our Telegram channel, not in the description box. So you can see it from there. If you face any doubts, you can ask in comment box. We are going to take up those doubts. Okay. So in the next session also, we will take up another chapter from your EAPCET series. I want to give you one more information and then we will end our session. And please practice more and more questions now from this part. We have covered all the important reactions. all the reactions, I will say. Most of them are asked in the questions also. I hope you have seen them, how many times it is being repeated and how they are asking you the exact same question in multiple different ways. Okay, so one information I want to share with you, and then we will end the session. Okay, so this is regarding our Maths 1 year program. So if you know about Sasya, we are starting with a 1 year Maths program for grades 3 to 10 in just rupees 999. So if you want to learn Maths from IIT and IT Exposed, you can join this program. You can take help of Sasya AI also. You can scan this and download our app, and the course will start from 5th. Okay, so I hope you tell your brothers and sisters who are in grade 3 to 10, or anyone who is in need of a maths program for the entire year in just rupees 999. Okay, so that is all from my side. I hope you like the session. Please practice more and more questions. And in the next class, we are going to cover biomolecules, easy peasy chapter, no numericals involved, but it is important. Okay, so have a great day, everyone. Thank you so much for joining the session. Bye, everyone.